This is Dr. P. Srilata, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, we are going to discuss about sampling distribution. So what is sampling distribution? So before going to start sampling distribution, so first of all, we will discuss about population. So what is the definition of population? The collection of objects. The collection of objects is known as population. The collection of objects is known as population. Or the set of objects is known as population. Or the group of objects is known as population. So, huge amount is known as population. Okay. So, it may be finite or infinite. It may be finite population or infinite population. So, for example, to the finite population. The students in a class may be treated as finite population. So, the students in a class may be treated as finite population. So, always population size is denoted with capital N, right? So, the students in a classroom may be treated as a finite population means, so for example, 60 students are there in our classroom. So, we have 60 students are there in our classroom. So, that may be treated as a finite population. That means finite means countable. Okay. So, countable population. So, if the population size is 60, then it is denoted with n equal to 60. Okay. So, the students in a classroom may be treated as finite population. That is nothing but, that is countable population. Okay. So, finite population is nothing but countable population. So, infinite population. The goods prepared in a factory may be treated as infinite population. So, it will produce many goods, right? So, that's why we can treat it as infinite population. Infinite goods will be there. Uncountable goods will be there. So, that's why we can say that that is infinite population. And we know that the population size is denoted with capital N. Population size is denoted with capital N. Okay. So, next definition is sample. Subset of population. Subset of the population is called as sample. A part of the population. So, the part of the population is known as sample. Okay. And the sample size is denoted with small n. And the sample size is denoted with small n. Okay. So, the subset of the population or the part of the population. So, for example, so the number of students in a class. Okay. The number of students in class let us consider those are 50. Okay. So, here I am choosing 5 girls. Okay. So, 5 girls. So, this can be treated as a sample. Okay. So, this is population and this is sample. Okay. So, this is population and that is sample. Okay. So, next one is sample size. If the sample size is less than 30, so we know that the sample size is denoted with small n and the population size is denoted with capital N. So, sample size is denoted with small n and the population size is denoted with capital N. So, if n is less than 30, so if n is less than 30, so we can call it as that is small sample. If n is less than 30 or the sample size is less than 30 is called it as small sample. So, next one is large sample. If the sample size is greater than or equal to 30, if the sample size is greater than or equal to 30, then we can call it as that is large sample. So, sample size is denoted with capital N. So, capital N is greater than or equal to 30. So, greater than 30 or equal to 30. The sample size is greater than 30 or equal to 30. Then we can call it as that is large sample. So, next very, very important definition, sampling. So, next definition is sampling. The process of choosing samples from the population. The process of choosing samples from the population is called it as sampling. So for example, so here the population, the students in a classroom may be 50. In this, I am choosing, in this I am choosing 5 students. Okay, so in this I am choosing 5 students. Okay, so the 5 students may be, so this is a sample and this is a population. Okay, so this is sample and this is population. So the number of students in a classroom may be 50 is population, and here I am choosing only 5 students. Only 5 students. So that is sample. Okay, so these are the samples. So the process of choosing samples from the population. That means here I am taking 2 girls and 3 boys. Or I am taking 1 girl, 4 boys. Or I am taking 0 girls and 5 boys, like that. Okay, so are 5 girls, 0 boys. So if I choose like this, so this process is known as sampling. So this process is known as sampling. The process of choosing. So the process of choosing samples from the population. So the process of choosing samples from the population is known as sampling. So next one is parameters. So x1, x2, x3 and so on, xn are parameters. x1, x2 and so on, xn are parameters. So that means those are population, right? So population. So we know that the populations are xi's. Okay, so that means those are x1, x2, x3, x4 and so on, xn. So we can call it as those are populations. Okay, so here the parameters are, so the mean, variance, standard deviation, these are the parameters. Okay, so in population, the population values are denoted with xi's. That means x1, x2, x3 and so on, xn. Okay, so these are the parameters. So we can say that this is nothing but population. Okay, so here we have formulas in population. So mean. So we know that the mean is denoted with mu. So mean is denoted with mu, and that is summation I equal to 1 to n xi divided by capital N. Okay, so what is capital N? We know that the population size is denoted with capital N, and the population mean is, so here the population mean is denoted with mu, and the population variance, here the population variance, so that is denoted with sigma square, and the population standard deviation is denoted with sigma. Okay, so remember these 4 points. So here the population mean, so that is denoted with mu, so that is nothing but average of population. Okay, so that means summation I equal to 1 to n xi divided by n. Okay, so and next one is variance. So variance is denoted with sigma square, and that is nothing but summation I equal to 1 to n xi minus mu whole square divided by n. So that means the sum of squares of means. Okay, so this is a sum of squares of deviations from the means. Okay, deviations from the means, or we can say that directly. So we can write this formula, that is variance is denoted with sigma square, and that is 1 by n summation I equal to 1 to n xi minus mu whole square. So these are xi is nothing but here population. Okay, and mean is population mean, and standard deviation. We know that standard deviation is nothing but under root of variance. So always standard deviation is denoted with under root of variance. So that's why standard deviation sigma equal to under root of 1 by n summation I equal to 1 to n xi minus mu whole square. So next one is statistics. Okay, so small x1, small x2, small x3 and so on, small xn. So actually these are statistics, and also we know that those are samples. Okay, samples. Okay, so statistics is nothing but sample. Okay, so statistics is nothing but samples. So here the sample mean is, so we know that the sample size is small n, and here the sample mean equal to, that is nothing but x bar. Sample mean is denoted with x bar. So that is nothing but average of samples. Okay, average of those samples. That means summation I equal to 1 to small n xi divided by small n. Okay, summation I equal to 1 to small n xi divided by small n. And variance, sample, this is nothing but sample variance. So sample variance is denoted with s square. So that is equal to 1 by n minus 1, summation I equal to 1 to n xi minus x bar whole square. Xi minus x bar whole square. So that is nothing but summation I equal to 1 to small n xi minus x bar whole square. So that is sum of squares of deviations from the samples and mean. Okay, so sample means. Okay, sample means sum of squares of deviations from the sample means. Okay, so that is and the variance is s square equal to, sometimes we can write s square equal to 1 by n summation I equal to 1 to n xi minus x bar whole square. Sum of this square, sum of squares of deviations from the means. Okay, so next one is sample standard deviation. Sample standard deviation is denoted with s. So sample standard deviation is denoted with, so in everywhere sample standard deviation is nothing but under root of variance. Okay, so here the sample standard deviation equal to under root of 1 by n minus 1. So what is variance here? The variance is 1 by n minus 1 summation I equal to 1 to n xi minus x bar whole square. So and sample standard deviation is equal to under root of 1 by n minus 1 summation I equal to 1 to n xi minus x bar whole square. So clearly, so you can understand that the samples, okay, so that is sample mean is denoted with n, and the sample mean is, sample size is denoted with n, and sample mean is x bar. Sample variance is denoted with s square, and the sample standard deviation is denoted with s. Okay, so clear? Next one is sampling distribution. So very important topic, that is sampling distribution. The set of all possible samples is called sampling distribution. The set of all possible samples is called sampling distribution. So here we have a note, that is in a sampling without replacement, the samples can be drawn. Okay, in sample without replacement, NCN samples can be drawn. Okay, so NCN, in without replacement, NCN samples can be drawn. That is sampling distribution from finite population. Sampling distribution from finite population. Okay, so like that, in a sampling with replacement, so n power n samples can be drawn. N power n samples can be drawn. So that is nothing but sampling from infinite population. Sampling from infinite population. Okay, so without replacement means we have to replace. Okay, we have to replace the samples. Okay, sorry, we have to without replacement means here we are not replacing. So without replacement is we are not putting any sample again. Okay, so in 50, the number of students are there in our classroom may be 50. So let us consider the population. The population, number of students in a classroom may be 50. That is nothing but population is 50. So here we are choosing 5 samples. Okay, so here we are choosing 5 samples. Okay, so in with replacement, again I want to choose one more 5 samples. Okay, so that means if I choose the second sample, so here I want to replace the first sample. So the first those 5 samples I am replacing. Okay, so that is nothing but with replacement. So that is with replacement. So for here also same. Here we have 50 students are there in our classroom. Here I am choosing samples, 5 samples first. Okay, so this is our first process. In the second process also I am choosing some 6 samples. Okay, in the 6 here I am choosing in the second process I am choosing 6 samples. So before going to draw 6 samples, here I am not replacing 5 samples. Here I am not replacing 5 samples. That means that is without replacement. So that is without replacement. That is nothing but finite population. Finite population. Okay. So finite population, in finite population we have to choose NCN samples. Okay, so in finite population or in without replacement, we have to choose NCN samples. We have to choose NCN samples. But in with replacement, here I am replacing these 5 samples. That means with replacement. So with replacement is nothing but infinite population. So infinite population. So in infinite population, we have to choose n power n samples. N power n samples. We know that capital N is nothing but population size. Population size is denoted with capital N, and the sample size is denoted with small n. Okay. Next, sampling distribution of means. We know that already we have discussed in the previous slide. So that is, what is sampling distribution? So the all samples are called sampling distribution. The set of all possible samples, the set of all possible samples are called sampling distribution. So the set of all possible samples is called sampling distribution. Here the sampling distribution is denoted with in the bracket, that is x1, x2, x3 and so on xn. So these are the samples. Okay. So with replacement. So for with replacement means that is infinite population. Already we have discussed about this with replacement. With replacement is nothing but infinite population. So here we need to choose n power n samples. In this case, we need to choose n power n samples. Okay. So for that we have a formula. So that is sampling, mean of sampling distribution of means. So mean of sampling distribution of means are the mean of the sampling distribution. Or we can say that that is mean of the sampling distribution and the mean of the sampling distribution of means. So both are same. So that is denoted with the mu x bar. Okay, so mu x bar, that is denoted with the mean of the sampling distribution is denoted with mu x bar. So that is nothing but summation xi bars. So here we need to choose xi samples. Okay, so the samples are xi, and here we need to find the sample means. That means xi bars. Okay, so here we are going to find xi bars, that means sample means. Okay, so after finding the sample means, we need to find the mean of the sampling distribution. So the mean of the sampling distribution equal to, here we have a formula. So that is mu x bar equal to 1 by n power n. So why we are writing 1 by n power n? N power n is nothing but here we are using with replacement. So in with replacement, we have to take n power n samples. So in with replacement, we have to take n power n samples. So that's why here I am writing mu x bar equal to 1 by n power n into summation xi bar. Xi bar is nothing but sample mean. Okay, so those are the sample means. Okay, so next one is variance of the sampling distribution, or the variance of the sampling distribution of means. So that is denoted with sigma square x bar. So that is denoted with sigma square x bar. So that is also equal to 1 by n power n summation xi bar minus mu x bar whole square. So summation xi bar minus mu x bar whole square. Okay, so here this is nothing but sum of squares of deviations from the means. Okay, So from the means, this is the sample mean, and this is nothing but mean of the sampling distribution of means. Okay, so mean of the sampling distribution of the sampling distribution of means. Okay, so variance of the sampling distribution in with replacement. In with replacement is sigma square x bar equal to 1 by n power n summation xi bar minus mu x bar whole square. So xi bar minus mu x bar whole square. So next one is standard deviation of the sampling distribution. The standard deviation of the sampling distribution of means. So we know that always standard deviation equal to under root of variance. Okay, so standard deviation equal to under root of variance. That means sigma x bar. So sigma x bar equal to under root of variance. Under root of variance, under root of 1 by n power n summation xi bar minus mu x bar whole square. Okay, so next, so in sampling distribution without replacement, sampling distribution without replacement. So without replacement is nothing but we are replacing the samples. We are not replacing the samples. Okay, so here we are not replacing the samples. That is nothing but without replacement before going to second draw. So before going to second draw of the samples, we are not replacing the first draw samples. So that is nothing but without replacement. So without replacement means finite population. So finite population without replacement. So that is nothing but finite population. In finite population, so in finite population, we have to choose NCN samples. We have to choose NCN samples. Okay, so in with replacement, that is nothing but finite population. So that is nothing but finite population. In finite population, we have to choose NCN samples. NCN samples. Okay, so we have formulas based on with replacement. That is, first formula is mean of the sampling distribution or mean of the sampling distribution of means. So that is mu x bar equal to, so that is denoted with mu x bar. Always mean of the sampling distribution. Mean of the sampling distribution is denoted with mu x bar. Okay. So here in without replacement, mu x bar equal to 1 by NCN. So because in with replacement we have to choose NCN samples. Okay, in with replacement, we have to choose NCN samples. So that's why mu x bar equal to, so mu x bar equal to 1 by NCN summation xi bar or sigma xi bar. Okay, so average of those samples. Okay, so xi bar is nothing but we know that those are sample means. Okay, so sample means. Okay, samples are xis. Okay. Samples are denoted with xis and sample means are denoted with xi bar. Okay. So here the average of, so those sample means. So in without replacement. So that's why here we need to write in the denominator, we need to write NCN. Okay. So next one is variance of the sampling distribution. Variance of the sampling distribution or variance of the sampling distribution of means. So that is always denoted with sigma square x bar. Sigma square x bar. So that is equal to 1 by NCN. Why we are writing here NCN? So because we are choosing for without replacement. We are choosing for without replacement. Without replacement is nothing but we are not replacing the first, second draw before going to, we are not replacing first draw samples before going to second draw samples. Okay. So that's why we are taking 1 by NCN. Okay. So that is here the variance of the sampling distribution is sigma square x bar equal to 1 by NCN sigma xi minus mu x bar whole square. So sigma xi minus mu x bar whole square is nothing but sum of squares of deviations from the means. Okay. So this is sum of squares of deviations from the means. So that is variance of the sampling distribution. Sigma square x bar equal to 1 by NCN summation that is nothing but sigma xi minus mu x bar whole square. So this is the formula for variance of the sampling distribution. So next one is standard deviation of the sampling distribution. So standard deviation is nothing but we know that that is under root of variance. Standard deviation is under root of variance. So that is equal to sigma x bar. So under root of variance, variance is 1 by NCN sigma xi bar minus mu x bar whole square. So sigma x bar equal to under root of 1 by NCN summation xi minus mu x bar whole square. So this is also sigma, no, that's why I'm telling that this is summation, okay. So we can say that that is sigma also. So sigma x bar equal to under root of 1 by LCN summation xi bar minus mu x bar whole square, because standard deviation is always under root of variance. So next here we have a note that is in sampling distribution, okay. So in sampling distribution, always mean of the sampling distribution is always equal to population mean. So here population mean is denoted with mu. And so what about mu x bar? So mu x bar is nothing but mean of the sampling distribution, mean of the sampling distribution. Okay, so mean of the sampling distribution or mean of the sampling distribution of means. Okay, so mu x bar is the mean of the sampling distribution of means, and population mean is denoted with mu. So here we observe carefully here. So that is mu of x bar equal to mu. Okay, so and that means, so always mean of the population is equal to mean of the sampling distribution. Mean of the population is equal to mean of the sampling distribution. But so observe here, so sigma square x bar is not equal to sigma square. Sigma square x bar is not equal to sigma square. So what is sigma square? Population variance. So population variance is sigma square. So what is sigma square x bar? So variance of the sampling distribution. Variance of the sampling distribution is nothing but sigma square x bar. Variance of the sampling distribution is denoted with sigma square x bar. But here observe, so sigma square x bar is not equal to sigma square. That means variance of the sampling distribution is not equal to variance of the mean. So variance of the sampling distribution is not equal to variance of the means. But see here, variance of the sampling distribution is equal to sigma square by n. So this is possible in infinite population. So this is possible in infinite population. Infinite population means, so with replacement. Infinite population means that is with replacement. In with replacement we can write variance of the sampling distribution equal to, so variance divided by, what is this, n is nothing but sample size. So what is small n? Small n is sample size. So variance of the sampling distribution is equal to sigma square by n. Sigma is nothing but variance of the population, or population variance is denoted with sigma square, and divided by sample size. So this is possible only in the case of infinite population. So here infinite population is nothing but with replacement. Okay. So like that. So one more formula is there, that is sigma square x bar equal to, that means variance of the sampling distribution is equal to sigma square by n into n minus n by n minus 1. N minus n by capital N minus n by capital N minus 1. So what is capital N? That is nothing but population size. Population size is capital N and the sample size is small n. Okay. So and population variance is sigma square. Okay. So and the variance of the sampling distribution is sigma square x bar. So observe carefully. So sigma square x bar equal to sigma square by n into n minus n by n minus 1. So this is possible only in the case of infinite population. So infinite population is nothing but without replacement. So this is possible only in without replacement. Okay, so here So main important note is here, always mean of the population is equal to mean of the sampling distribution. Mean of the population equal to mean of the sampling distribution. But variance of the population is not equal to variance of the sampling distribution. But variance of the sampling distribution is equal to sigma square by n. That is possible only in the case of with replacement. With replacement, okay. So in with replacement, we can write the variance of the sampling distribution is equal to sigma square by n. So R, that is nothing but infinite population. So this is possible only in the infinite population. So like that, sigma square x bar equal to sigma square by n into, and also along with n minus n by n minus 1. Okay, so this is nothing but correction factor. Okay, so this is variance of the sampling distribution is equal to sigma square by n into n minus n by n minus 1. So this is possible only in the case of without replacement. So without replacement, so that is nothing but infinite population. Sorry, that is nothing but finite population, not infinite. Okay, so without replacement is nothing but finite population. Without replacement is nothing but finite population. So that is possible only in the case of finite population. Okay. So variance of the sampling distribution is equal to sigma square by n into n minus n by n minus 1. Okay. So that is possible only in the case of finite population. So that is nothing but without replacement. Okay. So these two points are important along with this one. So next one is correction factor. So correction factor is nothing but n minus n by n minus 1. Okay. And the standard error. So capital N is population size. Population size is capital N, and the sample size is small n. Okay. So and the standard error, one more formula is there, that is standard error. Standard error equal to sigma by n. So what is sigma? Sigma is nothing but standard deviation. So standard deviation of the population, or population standard deviation. So that is denoted with sigma. Okay. Standard error equal to sigma by n. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.